Here's a question a human would ask. The top 3 products by revenue last quarter for each region. Now watch what we do not do. No loop, no sorting steps, no step-by-step instructions at all. We simply describe the answer we want, and a tidy table comes back. That's SQL. And that one idea is stranger and more powerful than it first looks. SQL is declarative. You describe the result. The database figures out how to get it. It feels like magic, until you learn the one thing the engine is quietly doing behind your back. Learn that, and every confusing rule in SQL falls over like a row of dominoes. First, why this still matters in the age of AI. Because the data does not live in your Python script. It lives in databases and warehouse, often billions of rows, far too big to fit in memory. SQL is how you ask questions of data where it lives, and pull back only the slice you actually need. And here's the part nobody tells beginners. In real data science, a huge amount of feature engineering happens in SQL before Python ever sees the data. Year after year, it is the single most requested skill in data job postings. So this is not legacy plumbing, it's a daily tool. Let's genuinely understand it. Chapter 1. Why SQL and the world it lives in. Picture where data actually sits. Rows in a database, a customer's table, an orders table, an events table, humming on a server somewhere, or in a cloud warehouse like BigQuery or Snowflake. You don't download it all. You send a question to it, and it sends back an answer. The data stays put, only the result travels. And the questions are declarative. You say what you want, not how to compute it. Compare that with Python, where you'd write the loops and the sorting yourself. In SQL you say, give me these columns, for these rows, group this way. The engine plans the how, and on a billion rows, it is far better at it than you would be. One more reason it's worth your time. SQL is nearly universal. The same core language drives Postgres, MySQL, SQL Server, BigQuery, Snowflake, even Spark. Learn the ideas once, and you can query almost any data system on Earth. Very few skills in all of tech have that kind of reach. One foundation before we build higher. Every column has a type, and SQL is strict about it. Text strings, whole numbers, decimals, dates, and timestamps. True or false booleans. The type decides what you're allowed to do. Maths on a number, calendar comparisons on a date, and the database stops you mixing them up by accident. That strictness isn't fessiness. It's exactly what keeps a billion-row table honest. Chapter 2. The relational model. Everything in SQL is a table. Rows and columns, like a spreadsheet, but strict. Every column has a fixed type. Every row is one record, one customer, one order, one event. A database is just a collection of these tables. Simple, rigid. And that rigidity is exactly what makes it fast and trustworthy. Two ideas hold it all together. First, the primary key, a column that uniquely identifies each row, a customer ID, no two alike. It's the row's name tag, the thing that says this row and no other. Every well-built table has one. Second, the foreign key, a column in one table that points at the primary key of another. An order's customer ID column points back to exactly one customer. That small link is how separate tables connect, orders to customers, customers to regions, into a web of related data. So a database isn't one giant sheet. It's many small, clean tables, deliberately kept apart, linked by keys. Customers here, orders there, products elsewhere. Which raises the obvious question we'll spend a whole chapter on. If the data is split across tables, how on earth do we bring it back together? And the thing that makes those separate tables powerful is the shared key, the thread running between them. A customer ID sitting in both the customer's table and the orders table is the needle and thread that lets you sew any two tables back together. Honestly, spotting which column two tables have in common is half of writing a good query. Train your eye to look for that shared thread. Chapter 3. Asking your first question. The heart of SQL is the select statement. Select the columns you want from the table they live in. Select name, city, from customers, and you get just those two columns for every row. Select chooses the columns from chooses the table. That is the skeleton of every query you will ever write. Then where filters the rows. Add where age greater than 30 and you keep only the rows that pass. Combine conditions with and or. Match text, ranges, lists of values. Select picks the columns, where picks the rows, and together, those two already answer a surprising number of real questions. Two small touches that make results far more usable. You can rename a column on the way out with as revenue times 0.9, as net revenue, giving a computed column a clean name, and you can compute right there in the select, price times quantity, or one date minus another. Select isn't only for picking columns. It's where you shape, calculate, and name what finally comes out. So the shape of a basic question is fixed and friendly. Select these columns from this table, where these rows qualify, then order by to sort, and limit to cut it short. Read it aloud, and it's almost English. But under that friendly surface, something subtle is happening, and it trips up very nearly everyone. Here's the trip up. Rename a column. Then try to filter by that new name in your where, and SQL slaps your hand. It claims not to know the name yet. Try to filter on a sum, and it refuses to. These rules feel arbitrary, even random. They are not. One single idea, in the very next chapter, makes every one of them suddenly obvious. Chapter 4. The Secret Order. Here is the secret that unlocks SQL. You write a query in one order. Select comes first. But the database runs it in a completely different order. And the moment you can see that hidden order, every weird rule from a minute ago simply explains itself. This is the most important idea in the whole video. Picture a kitchen line. First, the ingredients arrive. That's from your tables. A bouncer at the door turns some away. That's where filtering rows. What's left gets sorted into bins. That's group by. An inspector checks each bin. That's having. Only then do you plate what to actually show. That's select. You arrange the plates, order by. And finally take just the first few, limit. So the true running order is from, then where, then group by, then having, then select, then order by, then limit. Read that again. Select, which you write first, is cooked almost last. Now the puzzle from before. Why can't where use a column you renamed in select? Take a second. Because where runs before select. At that moment, the new name simply does not exist yet. And every other strange rule falls out of the same picture. Can't filter a group total in where. Because where runs before the groups are even formed, which is exactly what having, running after, is for. The order isn't bureaucracy. It is the recipe the engine literally follows. And holding this one picture in your head is what separates someone who memorizes SQL from someone who truly understands it. Here's the same idea flipped, just to weld it into place. You cannot use a renamed column in where, but you absolutely can in order by. Why the difference? Because order by runs after select, so by then the new name exists. Where runs before it, so it doesn't. Same rename, two opposite outcomes, one explanation. Where each clause sits in the running order. See it once, and you never memorize it again. Keep this kitchen line in mind, because later we'll add one more station to it. A powerful one for window functions that slots in right after select. But first, let's use the order we already have to answer real questions. Sorting, joining, and grouping. Chapter 5. Null. The unknown. Before we go further, meet the value that causes more bugs than any other. Null. Null does not mean zero, and it does not mean empty. It means unknown. We simply do not have this value. A missing birth date, a customer who never logged in. An unknown behaves in ways that surprise everyone. So let's diffuse it now. early, before it bites. Here's the classic trap. Predict it with me. You have 50 customers with a null salary. You write where salary equals null to find them. How many come back? 0. None at all. Because null means unknown. And asking is this unknown equal to null is itself unknown. Never true. The fix is special syntax, where salary is null. A plain equals will never find a null. And null quietly shapes ordinary filters too, where status is not equal to cancelled will silently drop the rows where status is null. Because unknown isn't noisily different from cancelled either. When you want a default instead, Callis steps in. It returns the first non-null value. So Callis of salary and 0 turns the unknowns into zeros. Hold on to null. It comes straight back in our aggregates. One more null landmine, because this one is genuinely nasty. Not in against a list that contains even a single null. Returns nothing at all. Silently, with no error. The whole logic collapses the instant an unknown sneaks into that list. The safe habit is to use not exists instead, or to strip the nulls out first. Null doesn't just hide a few rows. It can quietly empty your entire result. Chapter 6. Sort and Trim. To quick, satisfying tools. Order by sorts your result by any column, ascending by default, or descending for biggest first. Order by revenue, descending, and the top earners rise to the top. It's the last real step before the result is handed back, which is exactly why it can use names from select. It runs after it. And limit keeps only the first few rows. Put them together. Order by revenue descending, limit 10, and you've asked for the top 10 by revenue. Remember the very first question? Top 3 products per region. You now have the top 3 part. The per region part needs heavier machinery, and it is coming. Order by also takes several columns in priority order, sort by region first, then by revenue within each region. And because null is unknown, you get to decide where the unknowns land, with nulls first or nulls last. A small thing. But it stops your missing values from quietly floating to the very top of an important report. One cousin worth knowing. Select distinct, which throws away duplicate rows and keeps only the unique ones. Distinct cities, distinct user IDs, and paired with a count of distinct user ID, it answers how many different users, not how many rows. That one idiom, counting distinct things, shows up in almost every metric you will ever build. Chapter 7. Joins, bringing tables together. Now the heart of SQL, and the thing that separates beginners from the fluent. The join. Your data is split across tables. Customers here, orders there, linked by keys. A join stitches them back together. Watch the basic move, an inner join. For each order, find the customer whose ID matches and glue their columns onto the same row. Match on the key. Merge the rows. Now what about rows that don't match? An order with no customer. A customer with no orders. That single question is all that separates the join types. An inner join drops the unmatched. A left join keeps every row from the left table, filling the blanks with null. Right join keeps the right. Full join keeps both. Don't memorize 4 things. Just ask, whose leftovers do I want to keep? Here's a prediction that catches almost everyone. 3 customers. One of them has 4 orders. You inner join customers to orders. How many rows come back? 3, 4, or 6? It's 6. Each customer row is duplicated once for every order they have. That multiplication has a name, fan out. And if you don't see it coming, it quietly corrupts your numbers. Here's how it corrupts them. Say you join customers to their orders. Then sum each customer's account balance. Because the join duplicated that balance once per order, your sum is now inflated. Double, triple counted. It is the single most common silent bug in all of analytics. The fix? Aggregate first, then join, or count distinct. Whenever you sum across a join, ask yourself, did fanout just lie to me? And one more trap, this one with left joins. You left join customers to orders to keep everyone, then add where order date is in January. Quietly, you just destroyed the left join. The customers with no January order have a null date, the where drops them, and you're silently back to an inner join. The fix is to move that condition up into the joins on clause. Filter unmatched rows in where, and they vanish. Here's a join that bends your brain the first time you meet it. A table joined to itself. To find each employee's manager, you join the employees table to a second copy of itself, matching each person's manager ID to another employee's ID. Same table, two roles. Org charts, comment reply threads, who refers whom, anytime, rows relate to other rows in the very same table. That's a self-join. And a practical default worth carrying everywhere. For analytics, reach for left join first. You almost always want to keep every row of your main table, every customer, including the ones with zero orders, and let the matched data fill in beside them or sit empty. Start from the table you refuse to lose. Left, join the extras onto it, and you stop silently dropping the very rows your report is supposed to be about. Chapter 8. Group and Aggregate. Now we summarize, and if you watch the Python video, you already know this exact shape. Group by splits the rows into groups, computes something for each, and combines the answers into one row per group. Split, apply, combine. It is the very same idea as pandas group by, just wearing SQL's clothes. You learned it once. Here it is again, for free. The something you compute is an aggregate. Count how many, sum the total, average the average, min and max the extremes. Group by region, then select region and the average sale. And you get one tidy row per region, each carrying its average. Group the rows, crush each group down to a single summary number. That's the workhorse of every dashboard ever built. And null returns exactly as promised. Count star counts every row, nulls included. But count of a column skips the nulls. Average and some ignore nulls entirely. So an average is taken over the known values only, not the total row count. Miss that, and your averages quietly drift. The unknown doesn't get a vote in an aggregate, unless you count the rows themselves. Now filtering groups. Say you only want regions whose total sales top 1 million. You cannot use where. Remember the kitchen line, where runs before the groups even exist. So SQL gives you having, which runs after grouping, to filter the groups themselves, where filters rows before, having filters groups after. The order you learnt in chapter 4 just told you precisely which one to reach for. Two power-ups you'll use endlessly. Count distinct, to answer how many different customers, not how many orders. And date truncation, bucket a timestamp down to its month or week, then group by that, to turn raw events into a clean monthly trend. Grouping by a time bucket is how a fire hose of individual events becomes a chart you can read. Let's watch the kitchen line cook one full query. From the orders, where the status is paid, group by region, then having total above 1 million to keep only the big regions. Select the region and its sum, order by that sum, and limit to the top 5. Read it in running order. And every single clause has an obvious job. That one query is a real business report, and you can write it now. Dates deserve their own moment, because so many features are really about time. You can pull the year or month out of a timestamp, subtract two dates to get the days between, and bucket events into weeks or months. Days since last purchase, orders in the last 30 days, month-over-month growth. These time-based features are the backbone of churn and forecasting models. And they're all just date arithmetic, done in SQL. Chapter 9. Case when. Logic in a column. Meet SQL's if-then. Case when it looks at each row and returns a value based on a condition. Case when age under 18 then minor, else adult. In one stroke, you've turned a raw number into a clean label, a brand new feature. For data science, this is bread and butter. Bucketing, flagging, relabeling, right inside the query. And here's the move that feels like a genuine superpower. Conditional aggregation. Put a case inside a sum. Sum of case when status equals paid then amount. Else 0. And you've totaled only the paid orders in a single column. Do it several times across categories and you pivot a table. One column per category, side by side. A case inside an aggregate is how one query builds a whole feature matrix. You can lean on it anywhere a value goes. Bucket customers into bronze, silver, and gold tiers by spend. Flag a row as weekend or weekday. Convert a messy status code into a readable category. Anytime you would reach for an if statement in Python, case when does it in SQL, across millions of rows at once without ever leaving the database. One more place case quietly shines. Custom ordering. Say you want statuses sorted urgent, then open, then closed. An order the alphabet will never give you. Drop a case into the order by, mapping each status to a sort rank, and the rows line up exactly the way a human would want them. Case turns SQL's logic loose anywhere a value can go, even in how you choose to sort. Chapter 10. Composing bigger questions. Real questions get layered. Find the regions above average, then the top customer within each. You can nest one query inside another, a subquery, whose result feeds the outer one. It works. The inner query runs, hands up its answer, and the outer query builds on it. Powerful. But stack a few of these, and something ugly starts to happen. A subtle but important pair. Exists and inane. To ask which customers have at least one order, in checks against a whole list of IDs. Exists simply asks, does a matching row exist, and stops at the very first hit. Exists is often faster on big tables, and crucially, it sidesteps that not in null trap completely. Whenever you're testing for the existence of a match, exists is the grown-up choice. This, a subquery inside, a subquery inside a subquery. Technically correct and completely unreadable. In 6 months you'll open it, and you will quietly hate whoever wrote it. That whoever is you. Deeply nested SQL is where good analyzers go to die. There has to be a cleaner way to build up complexity. And there is. Common table expressions. The with clause. You name each step, one at a time, and stack them top to bottom like a recipe. With regional sales as this, top customers as that, then a final clean query that reads from them. Exact same result as the nested mess. But now it reads as a sequence of clear, named steps. This is how professionals write SQL. Not cleverer, just readable. Chapter 11. Window functions. Now the feature that genuinely separates analysts from professionals, and it begins with a puzzle. You want, in one single result, each employee's salary, and right beside it, their department's average. Both on every row, with nobody deleted. Group by can give you the averages, but it crushes the individual rows away. So, how do you get the summary and keep every row? Sit with that for a second. The answer is the window function. Picture a spreadsheet where you add a new column that is allowed to peek at neighboring rows without deleting any of them. You partition by department. That defines each row's window, its peer group, and compute the average over that window. Every employee row survives. Now carrying its department average right alongside. Group by collapses. A window looks around and keeps everyone. And the window can slide. That's how you get running totals and moving averages. You order by date inside the window and say which neighbors count. The frame. Rows between unbounded preceding and current row means everything up to here. A running total. One catch worth knowing. The default frame can sweep in tied rows you didn't expect. So for a true running sum, spell the rows frame out yourself. The window toolkit is small and mighty. Row number stamps a rank within each group, the top customer per region. Finally answering our opening question. Rank handles ties. Lag and lead reach to the previous or next row. Placing this month beside last month. So you can compute change over time. Ranking, running totals, period over period. The very heart of feature engineering, in a handful of keywords. One more window function feels tailor-made for data science. NULL. It chops your ordered rows into equal buckets. NULL of 4 for quartiles, 10 for deciles. Rank your customers by spend and split them into 10 tiers in a single line. Bucketing a continuous value into clean groups is a constant move in feature engineering, and NULL does it across millions of rows at once. One subtle thing ties it straight back to the kitchen line. Window functions run after grouping and after the select projection to that extra station we promised, late in the order. Which is exactly why you cannot use one insider where or a group by at that point. It simply hasn't run yet. To filter on a Windows result, you wrap it in a CTE and filter the next step. The order you learned predicts precisely when you'll need that wrapper. And for an AI audience, this is where SQL truly earns its keep. A staggering share of machine learning features are window functions. A user's average purchase over their last 5 orders, the days since their previous visit, their rank among peers, a 7-day rolling average. These are the columns that actually make models work. And they're computed at scale right here in the database. And now let's finally close the loop on our very first question. Top 3 products per region. Partition by region, order by revenue inside each one. Stamp a row number on every row. Then keep only the rows where that number is 3 or less. There it is. Top in within every group, the exact thing that plain order by and limit simply cannot do. The opening question, answered in full by a window. And that sliding window hands you smoothing for free. A 7-day moving average of sales, an average over a window of the last 7 rows, ordered by date, turns a jagged, noisy daily line into a clean, readable trend. Rolling averages, rolling sums, rolling counts, all the same frame idea, and exactly the kind of smooth feature that time series models quietly love. Chapter 12. Putting it all together. So watch the whole kitchen line cook one real thing. A feature table for a model. With the events from them, where the last 90 days, group by user for the totals, a window function to rank and to roll up recent activity, case when to flag the high-value users, and select the final, tidy features. Every tool we built composed into one readable, layered query, that is feature engineering in SQL. And once you've written a great feature query, you don't retype it by hand forever. You save it as a view, which is a named query that always reflects the latest data, or by materializing it into a real table with create table as. Your carefully built features become a clean, reusable dataset that the rest of your pipeline and your models can simply read from. Write it once. Use it everywhere. One last practical idea. Speed. Why is one query instant and another crawls? Very often, indexes. An index is a presorted lookup the database keeps on a column, so it can jump straight to the matching rows instead of scanning the whole table. The very same idea you'll meet again, deeply, in the algorithms video. You don't need to master tuning, just know the lever exists, and why key columns are worth indexing. And the golden division of labor. Push the heavy work to SQL, pull a small, clean result into Python. Let the database do what it is brilliant at, filtering, joining, and aggregating billions of rows where they live, and hand Python a tidy little table to model. The best data scientists aren't Python people or SQL people. They're fluent at handing each job to whichever tool does it best. So here's the whole of SQL on one breath. Data lives in linked tables. You describe the answer you want, and the engine runs it in a hidden order. From where, group by, having, select, then windows, then order by. Joins bring tables together, minding the fan-out. Group by summarizes. Case when engineers features, windows look around without deleting rows, and CTEs keep the whole thing readable. That is the toolkit. And remember where we began. That plain English question, top 3 products per region, answered without a single instruction on how to do it. It was never magic. It was this, a pipeline, running in this order every time. Learn the order, and SQL stops being a bag of arbitrary rules and becomes something you can reason about and even predict. You don't fetch data anymore. You ask it questions. So the next time you face a wall of data, you'll know you don't have to move it or loop over it. You just have to describe what you want in the right order and let the engine do all the rest. Subscribe for more such intuitive videos.